here for question 5, I wanted to look at the predicted genes for this plant here. I wanted to find something that I thought would be cool for you to see. Oh, I know this thing. And the sequence that I wanted to look at has this gene bank number. So all you do is you copy that number and you throw it in BLAST. And I did that. So I'm doing the BLAST N. And in my first pass, I pretty much always just leave it as the default database, which is the nucleotide database. From the drop-down menu is just the first one as the default. And I'm always hoping that because this is the largest database, it will match something that tells me some function. And then I look here and I go, oh, okay, really no such luck. So this is just saying, okay, it's saying where there's the sequence, which organism. So, okay, maybe I got the sequence from that, so I already knew that part. And then, okay, which part of the chromosome? It says it's from the centromere, and it came from a bacterial artificial chromosome clone, whatever. And then all these other matches are all like chromosome. Oh, maybe there's a duplication because it looks like it appears in chromosome 1 also and chromosome 3. So when I go down here, I'm like, mostly genomic information. Like, I don't see genes here. So I go like, all right, doing the nucleotide database, probably not the best idea. So I narrow it down to genes. So let me show you where you change that. So there is the accession number or the gene bank number. Here is the default that looks at every nucleotide of all the organisms that are on the database. And then for the RNA, I select this one, reference RNA sequences. I select that and I run it. And when I run, I get this sequence. And you can tell that here's my reference sequence RNA. And a lot of predicted. So I uncheck that and I only check the ones that seem more interesting in terms of there's biological information about it. So somebody sequenced that, somebody sequenced that. So they isolated the molecule and sequenced that molecule. And then I look in the graphic summary and where do those match? And because that sequence is really long, so you see 97,000, then my matches look really small, but it's just that this is really long, and then these matches, they look really short because of the scale. But they look like they're all different genes. See, they're all matching different places within that genomic sequence. And these guys are not connected by lines. So that tells me that these are each separate hit. Okay, these two would be sequences that they both match that region of the genomic sequence. So I count these as how many of these in this genomic sequence, how many genes match that. So there's one gene for this part, one gene for this part. So 3, 4, 5, and then 6. So let's see what these two matches are. It's hard to get it when it's so zoomed in. Okay, oh cool, it's a resistance gene. I don't know, they're my favorite. So Hobbs activated resistance gene 1. Let's see what this one is. It could be a variant of that gene. Let's see. Yep. So they're both resistance genes. So that was my bet because they match the same genomic sequence. And we could look at the description to see where are those Here is one. And okay, it's predicted ones. I'm not super interested. It said hops, something like that. Oh, there you go. And that's why they got two. One is full mRNA, the other one is a partial mRNA. And talk about partial mRNA. Sometimes we sequence the mRNA from the ends. Well, we always sequence from the ends, but sometimes the ends don't meet in the middle, and meaning we didn't sequence long enough for you to find overlap between the two sequences, as you guys did when you're building contigs. So those short sequences from the ends of the mRNA, they're called ESTs. So I also ran one search where I used ESTs on the database to see, do we find anything that is different or interesting. But I wanted you to know that when you think ESTs, you could think of it as also mRNA. And these are all connected, not because they are the same gene, but they were the same collection of ESTs. So I was like, okay, this is kind of misleading. So it says pooled cDNA populations. That just means that they sequenced all that and they all came from some pool, but not necessarily from the same gene. But the point of me showing you this screen is to tell you that EST is also a database you could use to find if there is a match. But now that there are so many mRNAs, the ESTs don't use it as much. So this one finds you lots of hits, but not necessarily genes. This one will find genes because they are sequences that have been transcribed. And then this one, it's a smaller pool nowadays, used to be larger, but they also represent mRNA sequences.